So we are on episode 22. We're kicking off the February, which is a rectangular month this year. I did not know this. Somebody tweeted about this totally random meme of like her day kicks off the month that looks like a perfect rectangle on the calendar, and it looks 4 weeks of February that look exactly like a rectangle. So it's
shortest month of the year too, right, Den? I think I saw that.
Yes. And so on this special month, we have a special guest, and that is Paige Bailey. Welcome, Paige, to
Awesome.
our show.
Excellent. I am very glad to be here and very excited to talk a little bit about machine learning and about all of the great stuff that you guys have been doing and that we've been thinking about at Google and at DeepMind.
I like that this conversation is so comfortable that you jump straight into, I'm excited to talk about these things. And we have this list of questions. Hold on. But okay, so Paige, for folks that don't know what you're doing, and I'm sure a lot of them follow you on Twitter and they probably know, and you're going to be repeating these things, but tell us more about what you do.
Absolutely. So I am a relatively newly minted product manager for DeepMind's research platform team. DeepMind, you can think of it as kind of another business unit within Alphabet. Alphabet is the parent company of Google and of Waymo, which is a self-driving car company, and of several other efforts that you might have heard of. But DeepMind, Google Brain, they're both research organizations within Alphabet. So as a product manager for the research platform team, I help support the great work of all of the research scientists and engineers who are doing things like building AlphaFold, which helps with drug discovery and can also do things like suggest vaccines, and AlphaGo, which was the model that was able to beat a human player at Go. AlphaStar, and all of the other really nice reinforcement learning projects. And prior to that, I was at Google Brain, managing all of Google's machine learning frameworks. So that is TensorFlow, JAX, and also Keras. And before that, I was working with Den at Microsoft, and really loved my time there as an Azure cloud advocate. Focused on machine learning and AI, and then also as a senior software engineer in the office of the Azure CTO.
So that's a lot of stuff, and I'm just gonna tell you up front that like AI is definitely not my strength, and so help me as a new person to the field understand how pervasive AI is in the world we're in today. I think understanding that helps people like realize that it's deeper than you would think in our daily lives, and it's impacting more things than you would expect. I know just my cursory knowledge of it is that it really is kind of everywhere. It's behind almost any product that we're using today, right?
Awesome. Like that's an excellent question. And I agree wholeheartedly. Like AI is, something that Google cares a great deal about. We consider ourselves to be an AI first company. And pretty much any Google service that you use has a TensorFlow model embedded within it. So an example of this would be if you have a Pixel phone or an Android device and you use kind of the speech to text functionality, congratulations, you're using a TensorFlow model. Or if you've typed an email into or started typing an email into Gmail and it's done autocomplete for a few additional words, congratulations, that's deep learning. And it's
we're doing your Google search, right? Like everybody's using Google, or everybody has used Google and knows that it recommends things as you're typing.
Exactly. And so that is a particular library called TF ranking. Likely best candidate for what you might be searching for based on a large history of previously searched for products. And so it's not just Google though. So like if you go on Amazon, Amazon.com, and you're searching for products, and it sort of suggests products that you might also be interested in. That's also a ranking algorithm. Same for Netflix. like the nifty, Teams backgrounds and Zoom backgrounds where, the person is still in the camera, but, it looks like you're on a beach, or climbing a mountain. That's something called image segmentation. And that is also, congratulations, deep learning embedded within a browser to be able to facilitate some of this work. So it's been really magical for me to see in particular how all of these products that I've helped sort of create have been deployed throughout the world, and the creativity of users as they're coming up with these novel use cases and these ways to help people. Everything from drug discovery to detecting diabetic retinopathy and X-rays to like suggesting what I should watch for my next Netflix binge. Like it's really nifty.
So in tech, being in the tech world, I'm a designer, but I don't work really closely with the closest I get usually is search algorithms. So I'm working with search interfaces and learning how they're tuning AI models for that, or we're monitoring analytics and that type of thing. But I rarely get to see AI applied outside of hard or not, just kind of dry technical situations. And you mentioned medical discoveries. What are some of your some of your favorites or heartwarming applications of AI that you've seen in the world, and it might not be Google, it might be anybody using it, or Google technology or Microsoft technology, but what's going on out there that's just amazing with AI that you can tell us about?
Yeah, that's another really wonderful question, and I agree wholeheartedly. The magical parts of AI are seeing it really help people and improve their lives. The Terminator use case is certainly very far away. But if at all, some of my favorite examples. Microsoft has something called Seeing AI, which can help people who are without sight, do things like program, or be able to navigate the world through the descriptions of what a video camera on a phone might see, right? So it's using deep learning to be able to understand, this is the sidewalk, these are some trees, it looks like there are two people approaching, helping empower people who are differently abled. I think that's one of the most meaningful ways that deep learning can impact everyone. I've also been really sort of enchanted to see the way that deep learning is used for energy optimization. So being able to optimize the power consumption in data centers. DeepMind had a collaboration with Google's data centers to sort of reduce the carbon footprint of how much the compute is using within our data center sources. I think Microsoft also had a similar project. But that is, as a former geophysicist, that means a lot to me as well. And then also, deep learning has been used to detect exoplanets, to be able to sort of understand space, and to bring new life into some of the satellite imagery that had been initially analyzed by humans, or maybe by sort of less powerful techniques, but now the data can be reused and sort of spot all of these things that we had missed before. So I really love the idea of machine learning not being like a people replacer, but more like a way to sort of enable and empower and improve the lives of humans, and be like a helpful assistant to help answer questions.
Yeah, and I think that a lot of people look at AI or automation as like an enemy, when in fact it's like an augmentation of like processes we don't really want to be doing anyways. And like, can we open up our talents to, more artistic endeavors, or like just spend more time, with other humans. Like, we don't have to do this stuff that can be done by a computer. But I think that, like I mentioned, a lot of people look at it as like making you obsolete, when in fact it just creates more opportunity for us, and it propels us forward into things we don't even know about yet.
Absolutely.
Dan, go ahead, man.
No, I actually had a good question that dovetails something that Paige already mentioned, and that is related to your career. So you mentioned you've been a geophysicist, and I kind of want to zero in. You're doing a lot of work with AI today.
Yes.
But what started it all? Where did it come from? Like the passion for AI, the passion for communities, because you have a pretty remarkable career. You started in GIS, you worked with data science, you work in advocacy, and now you're essentially product managing for AI.
Yeah.
How did it all start? Tell us more about your journey.
Yeah, so I do absolutely have a very wonky career path, and I am so grateful for the opportunities that I've had to grow and to kind of gradually move into this machine learning space. And it makes sense. It makes sense in some respects when you just remember that machine learning and deep learning are just like fancy math. Like it's just I've always really loved linear algebra and differential equations and all of the rest of the things that we're all taught in school. And my path in undergrad, I did geophysics and applied math. And my thought process was, I'm going to be Lady Carl Sagan. Like I am going to be able to be a science communicator for planetary science purposes, which were I was able to get like 2 really wonderful research internships at the Laboratory for Atmospheric and Space Physics in Boulder and at Southwest Research Institute in San Antonio. Our teams were understanding lunar ultraviolet, and sort of the presence of water ice in these permanently shaded regions on lunar surfaces. So if you remember, there was like this project where they had a rocket and they like launched it and it crashed into the moon, and then they monitored the ejecta. And that was one of the things that I got to be involved with. So building GIS lunar ultraviolet maps, and sort of spotting statistical anomalies and these massive sources of data. And so now, like, if you describe this to anyone, they're like, oh yes, data science, machine learning. And back then it was just like, oh yes, research. And so kind of by virtue of doing this data analysis work and working with GIS and starting to do Python programming, both as part of my applied math courses and through these GIS courses, I got a job opportunity at Chevron to build some databases for them, but also to create geostatistics plugins for some of their earth sciences applications, which again, we're doing sort of more traditional machine learning. This was back in 2013. But still definitely machine learning, though nobody really called it that, or data science, because those terms just didn't exist yet. And so once, Harvard Business Review came out with a couple of articles that were like, data science is the thing to do. They were like, hey, that's what Paige is doing. Let's just call her that now. That's kind of history. And I was also very fortunate in that all of this was happening in Texas. So I founded PyLadies in Houston, which is an open source Python user group for women and, for pretty much anybody that wants to come though. And also many of the data science companies like Anaconda and Enthought Canopy, are based in Austin, and we're leading these really vibrant communities. So I got to get involved with open source when I worked at Chevron, and that I think really spoke to some of the people at Microsoft that were building out the cloud advocacy program. And like I am just so delighted that I was able to work in the cloud space, specifically on data science and machine learning. And then that, kind of naturally transitioned to open source machine learning frameworks at Google. So
some of that sounds like you were in the right area at the right time to like kind of
yes,
like
absolutely.
continue to give you a slow trickle of like interest and like keep you on your toes, right? And like learning. As a kid, did you ever see yourself working with this like
oh my God. No, I am so lucky. I am so lucky. Like I grew up, I am actually dialing in today from Waco, Texas, the bustling metropolis of Waco, Texas, which is actually much larger than it was when I was a kid. I grew up in a small town, kind of a 30-40 minute drive away from Waco, called Itasca. Itasca, Texas, and it has 1,300 people and just as many cows. And my first experience with a computer was an Apple II that my mother salvaged from being thrown away from our local school library, because the town does not have a regular library. And an electrician friend helped us get it working. I started programming with BASIC when I was like 8 or 9 years old. But the Apple II was pretty much my only toy. So I learned how to use it. And I had never really imagined like computer science or programming as a career choice, because it was fun. And like, who pays you to do the fun things? So
it's amazing how just having a device or having access to something can totally change your life. I know that I grew up in a town very similar, basically replaced the cows with corn, and you have my, beginnings in it. I had a friend whose mom was a professor, and she exposed me to a lot of literature and things like that, and they happened to have a computer that had internet, and her husband was a designer, and he worked from home. So like some of that, like it definitely influences you, right? Like, and so for your experience, having that device, that one guy that was able to repair it, what a life changer that is, right?
Exactly.
It's kind of cool to see how that has played out for you.
Yeah. And it's and for you as well, right? Like there's something magic, I think, about having there's something magic about learning something when you're a child and like being captivated by it. And it's something that you really never forget. Like there's a reason why I can still recite like all of the Pokemon, and like have problems talking about all of the molecular structures of in biochem, right? Like it's but it's it's I'm so fortunate.
You're
and
like, how is that information relevant right now? Why are you in my brain still? Like
exactly.
So I actually am curious now that we're talking about the various kinds of learning, and you've been fortunate as a child to have kind of the means to do that. I'm curious in terms of kind of the learning routine. What is that like for you? Like, because when we're in our early age, I want to say we have a lot of time on our hands where we can just sit down and like tinker with computers. When adult life kicks in, that time just kind of vanishes because the day-to-day stuff comes in. You have to do a lot of these responsibilities, pay bills, whatnot. And for you personally, I know that I follow your Twitter, and I am constantly fascinated by the things that you post in terms of new research papers. And how do you structure your learning, right? Now that you're working professionally, I think that's a question that is interesting to not only folks early in the career, but anyone in their career, because you have to create time to research the space, to better understand it. How do you go about solving that problem?
Yeah. So, and I will say the same thing to you as well, Den. Like I am shocked and intimidated by the amount of content that you're able to produce about the stuff that you're learning. Like it is great to see, but it's also like, wow. Like and to be honest, it's often a reminder like, oh, I should go read that paper. But it's I found that as I've matured in my career, it really helps to be mindful and to be choiceful about how to set aside time. So like making sure that if I do need to answer emails, and I know that I need to answer emails each day, I'm going to set aside, 40 minutes in the morning, 40 minutes in the afternoon, and I will be hyper focused on solving those tasks during that time. And then like hyper focused on whatever chunks of other time I have later in the day, whether it's meetings or whether it's like, okay, I'm going to go through, there's this great, and I'm typing it into the chat so folks can read it later. There's this great website called Archive Sanity, which was created by this guy named Andrej Karpathy. But it takes all of the machine learning and data science papers from Archive and aggregates them into one single location. So I don't have to do like the mental guesswork of attempting to find out which are the most compelling papers for me to read today. The other things that I really love are kind of modular courses. Like I used to be really into Data Camp, but also Coursera and its kind of approach towards 5-minute videos, 10-minute reading snippets, things that are really bite-sized that you don't have to devote hours and hours of a day, that you can just pick up as you're walking to your next location. And also like Kindle has just been like some sort of crazy drug to me. I got a Kindle and realized that you can rent books from libraries for free. Like, and I feel like nobody told me this maybe earlier in my life because they realized how hard it would be for me to like not do that all the time. But like having the ability to pull down any ebook from anywhere, from any library, and then just like read it and like document it and highlight it however I want without having, its physical presence as a reminder in my house of how I like abuse my books. Like this is just amazing.
Not only do you have the internet, now you have access to an endless library, right?
It's crazy. It is absolutely absurd. And so and again, like touching back on y'all's points from earlier in the day, right? Like as an 8-year-old, 9-year-old kid, I could have never imagined this. Like Project Gutenberg, whenever I first saw it back, I forget what particular year, but I remember I was very young and all I could think of was just like, oh my God, there's a text file of Little Women on the internet. Like I'm going to be reading all day, like these older books. So it's just, it is, and the other thing is always to be mindful that there's always going to be more to read, that you're never going to be able to read all of it, that you're never going to be able to sort of consume all of the content in the world. But like what you do consume, be mindful about it, be choiceful, use aggregators when you can, and then also never forget to be hands-on. Like as a product person in particular, especially a product person for a machine learning API, like you need to be programming all the time or as much as you can in order to understand the friction and the frustrations of your users.
And I just want to say like a massive shout out to whoever manages Archive, because I think it's Cornell, right? It's Cornell University. That I use that as a hobby weekend reading where I go in on a weekend and say Twitter sentiment analysis. And then you get all these papers that just pop up with somebody has already done the work for you. Yep. And it's just a matter of implementing. It's a wonderful, wonderful resource.
Yep, I agree. And if you haven't had a chance, Kaggle also has a number of its kernels and notebooks available from people all over the world doing excellent work. Submitting their models for public competitions. And then all of those notebooks are available as resources, fully documented for people to review afterwards. So if you ever have, that Stack Overflow, GitHub, holy moly, GitHub, like all of these, content sources where if you want to understand how to use pandas to do a thing or use scikit-learn to do a thing, somebody's probably already done it. So you can just go out and find it. Like it's wonderful.
I feel like at some point we need to do a reunion episode with our good friend Meg Reisdell, who we had a couple episodes back. She's a PM on Kaggle, and we can just all nerd out on reusable curtains.
Yeah, the three of you, I'll just sit that one out because that would be over my head. But yeah, awesome. You know, it seems like AI, you're just like any other specialty, you're going to have put in the 10,000 hours to become a master, like really dedicate yourself to wanting to learn and wanting to be curious. How important was it that you have like a background in AI to be successful in the field? How often have you bumped into people that have went like a non-traditional route and you're working with them, or, you know, what would you have to say about that? Like traditional versus non-traditional education, lay it out there for us.
Awesome. So I am a huge believer in put your energy and your confidence in people, not in acronyms. I don't think that academic background has any sort of indication on how curious or creative or talented any person is. And you know, having a computer science PhD does not mean that you are any better at asking questions or being empirical than any other human in the world. And actually, computer science degrees are often, or at least I've found, less influential than coming from more of a science, or even like a sort of a cognitive science or an English background, to be honest. And, you know, the magic often happens in the margins. It's people who are coming with this domain knowledge and have, you know, deep insights into whatever they're specialists at. And then are just using Python or machine learning techniques as a tool to help better understand their customers or better approach problems. Because like the entire space of applied machine learning is just amazing. We've only started touching on it. Like I'm not sure if you guys are familiar with distill.pub. Which is a sort of a journal for machine learning, but it really goes into deep insights into how you would explain machine learning to someone who's not necessarily a computer scientist or has the AI background. And it was started by someone named Chris Olah, in addition to many other colleagues. But Chris, I believe, was hired by Google Brain just out of high school. So maybe went to college for a little bit, but certainly didn't have an undergrad degree, and is one of the most delightful sort of machine learning authors that I have ever experienced in my entire career. Like, he has this way of succinctly capturing these very complex ideas into really straightforward visualizations and terms. But this was a very long-winded way of saying, like, machine learning is kind of magic, and that, you know, just as math is ubiquitous, no matter where you go, no matter which field, statistics is ubiquitous, so is machine learning. It can be applied to anything. And like, I truly think that if you're interested in solving interesting problems, it doesn't matter what your background is. Like, there are tools that can help you do that with machine learning.
I'm actually curious, because when I started digging into machine learning, it was very intimidating because everything is so math heavy. And I love math. Don't get me wrong. It's great. Linear algebra, absolutely my thing. Statistics, absolutely my thing. But it's a lot to just drink from a fire hose when you just get started.
Yep.
For folks that are just breaking into the field, what would you recommend they do to kind of overcome this initial stage of, oh my gosh, this is too much?
Yeah. So I agree I agree wholeheartedly that the math can look intimidating. And one of my favorite anecdotes about this is, mathematical notation is kind of a gatekeeper, I think. Many of the most impactful mathematicians and physicists did not even adopt mathematical notation as it exists today. They came up with their own notation. Because the important thing isn't really like understanding how to manipulate these variable symbols. It's just like understanding relationships between things. So I think a lot of the time the math is needlessly heavy. That people are like really too eager to put complicated looking equations on slides or in papers. I disagree with that approach. So things that are helpful to kind of combat, and to show that it's not really as complex of math as you would think, is this distill.pub that I mentioned before. And there's another book that is just delightful called Hands-On Machine Learning with Scikit-learn and TensorFlow. This is from a man named Aurelian, who is phenomenal. He is currently living in New Zealand and like making all of us jealous. But this book, the latest version and the earlier version, are very great at explaining machine learning and machine learning concepts in simplistic terms, and not going too heavy on the mathematical notation. Because really, like, especially reinforcement learning, it's just very simple ideas, right? Like you have an agent that acts on an environment. So you have an environment that's created with a whole bunch of rules. The agent acts on the environment. If something good happens, then the agent is rewarded. So it does more of that. And if something bad happens, then the agent is kind of punished and like remembers, oh, I shouldn't touch that thing again. And then all of that is saved in a learning step. So if you act and you learn over enough iterations, then eventually you learn how to interact with an environment. And but all of that is very simple, right? Like that is, there's nothing fancy about it. It's just, the way to go about understanding.
I think there's an interesting tangent to that. Is I was reading a book recently on PyTorch, and I blank on the name, but I'll put it in the show notes. But it was one of those books that exactly like you described, where it goes in depth about these concepts around deep learning. Here's how to apply it to cancer imagery and how to detect all, the tumors in X-rays. And it just explains it so well without using any mathematical notation. It's like these stick drawings. And to me, this is like, wow, this is talent when you can explain something so complex in terms that if I read this book, I have zero background and I just get it.
Yep.
It's, I think it's an underappreciated talent for people teaching stuff the right way.
Yep. And it also requires humility, right? Like I think that there's and I don't really have data to back this up. So this is just kind of a personal opinion, but it often feels like in academia in particular, there's this devotion to very specific words that are or very specific terminology, which is often a gatekeeper. And if anything, science is all about communication. And if it doesn't matter if you create the best tool in the world, if you can't explain to people why it's useful and why they should go about considering using it, or like what a particular problem is, and trying to inspire them and empower them and to make them feel like they can do meaningful research and work in this space. But anyhow, like I think that the world could use a great deal more humility, especially from experts.
So in that regard, and if we're talking about numbers, I have a question about metrics. And I know that one of your principles that you've outlined on your website is bring data to opinion fights, which I absolutely love. I think this is the right approach. How do you get other people to care about metrics? because it's easy to say that everyone should care about metrics. We can define whatever you want. How do you get everyone else to care?
Awesome. That's a great question, and it also I think it has to be kind of hammered in from like project launch, especially for products, and it's so easy to get attached to the wrong metric, right? Like focusing on like revenue rather than customer retention. Or focusing on like pip install counts or GitHub stars instead of like, well, how are these people actually using it? Like, are the customer segments that we care about actually using our product, or is it just random containers downloading a thing? And I think to get people to buy into metrics, they have to be stakeholders, and they also have to have it has to be a team discussion. Like it can't just be a PM showing up and saying like, well, I think we should do this. It has to be okay, well, let's think of what our actual objective is. Like what would we really enjoy to have happen? How can we have the most impact? What do we want to have happen? All right, now let's all talk about and discuss like how might we go about sort of testing a hypothesis about this thing that we want to have happen. And once that's done, how do we define the metrics to determine whether we're successful? And if you bring people along on that journey and you use it as kind of like a storytelling exercise, it's a little bit easier to get people to buy into metrics. But usually I've found that the most impactful metrics are really these, sort of combinations of insights that help you better understand customers, as opposed to just picking like money or speed or whatever it happens to be.
Yeah. On that note, I wanted to share a little bit of my story working with that, because I spend a lot of time in the qualitative realm. Like I'm talking to users, or like I'm going to be doing a lot of interviews. I'm going to be watching people use a product, or just kind of getting like sentiment and like collecting anecdotes and like verbatims and things like that allow us to better understand the way like people's minds are working. It's not so much about like having a raw number. A raw number is great, and there's certainly times that we try to like balance out our qualitative with that. But one thing that's really bothered me in the past, I work with some product managers and they're really quant based, and they want to have like really hard numbers that go in the opposite direction of maybe what we've heard from a qualitative session. And like your gut and my instinct gets a little bit triggered, right? Like it's, yeah, of course the number says that, but I don't know that that's entirely the right thing that we need to be monitoring or measuring. Yep. Or using as like a benchmark to make a decision against. It's like we're watching the wrong thing, and we're not optimizing for the thing that matters the most, which is the human brain, or the way in which they want to use the product. You're missing it. Like the number doesn't tell you stuff. It doesn't show you everything.
Exactly.
And so, yeah, like how do you balance that? Have you experienced that yourself?
Oh, absolutely. And I love that you said this, like the marriage of qualitative and quantitative, like you can't choose one and then, ignore the other. One of my favorite papers, and I will send this to both of you. It was authored by a professor at University of Washington named Amy J. Coe. And what she did was she sat with 17 Microsoft engineers. So she was physically present in a room with them for 90-minute segments, and was hand documenting like whatever they were doing throughout their day. So 10 minutes spent programming, 5 minutes spent doing bug triage, and then 2 minutes spent reproducing the issue, and then 5 minutes more on bug triage all throughout the day. And they had these beautiful graphics displaying like what the fragmented nature of work looks like for software engineers for these 17 people. And they had additional data such as like years of experience and like specific kinds of teams that these folks were on. But what was fascinating to me was that they coupled this observation study with a survey where the users were asked, how do you seek information as you are going through tasks during your workday, as you're programming, as you're doing bug triage, etc. Like, what are the things that you use as resources the most? And like, people would report back with like, oh yes, well, I look at the metadata for CLs that are, and I looked at, the internal documentation and all the rest. When the reality was, and this was, only evidenced through observations, was that they would like yell across the hall to their colleagues, hey man, why did you name it this way? Or like, where is that thing located again? Or, I don't understand this behavior, please help me out. And in the survey, they had, all of the people uniformly had said, oh, like sometimes I ask my colleagues questions, but really that's like the fifth thing that I do maybe. And so I really think that if you rely fully on surveys or you rely fully on telemetry, you miss a lot of the insight that you can only capture through user experience work and through doing these sort of observational studies for users and how they're actually approaching your products. So.
Well, as you know, even the way you ask a question or the way you observe someone can dictate the way in which the result that you receive back. So,
yep.
That qualitative side is even an art in and of its own right, like trying to figure out how to write questions properly and, not leading people. And and people get that. What do they call that? There's a term for it, but like they perform when they know they're being watched.
Yep.
So yeah, great stuff to hear.
Mm-hmm. Cool.
It's interesting to also see how important it is to look at the right data, because even things like surveys or qualitative research can be flawed, just like data can be flawed if you are not following specific parameters for, like Courtney called out, asking the right questions or asking a lot of follow-up questions, because it's very easy to take the surface level insight and go to your team and say, well, customer said X is the truth, so X must be the truth, instead of asking, well, why? Or what else is out there? In that regard, I have again, kind of tangential question to what we just talked about, but how do you go about making sure that you're looking at the right things? Not just that you're actually looking at data, both qualitative and quantitative, but that it's actually the right data.
Yep. That's an excellent question. And I think this is also like one of the reasons why I love working so much in diverse teams and in teams with people who come from many dissimilar kinds of backgrounds. Because the best way that you're able to spot gaps in data sets and gaps in sort of information coverage that you have is by having people with varying experience ask questions and sort of all address it at first, instead of having a data scientist work in a corner attempting to understand if like this lens with which they're viewing the world is really the only lens that truly exists. Like there was a survey that I was looking at the other day. Like there's the Stack Overflow developer survey, obviously, and then there are many others that are sort of put out into the developer community, and most of them are targeted in aggregate. And don't really, address a particular user segment. So like, if I care about data scientists and machine learning engineers, like, do I really care what a C-level exec thinks about a particular tool? Or do I really care what a JavaScript developer thinks about this development environment? Encouraging questions about data. And then also making sure that all of your customers are represented, that if you are sort of using data to segment your customers, that it's really every insight that you do have. I don't have any easy recommendations for it, other than you really have to care about your customer and your people. It's always easier to probably just pull from the data that's available, but to be right and to be useful, you have to put in the extra work to get this multidimensional approach. Like there was a thread going around on Twitter earlier this week about hiring practices, and I like to think about this from that context as well. Like if you're interviewing someone, you get kind of a one-dimensional value for that person at the end of each interview cycle. And there's really no way to reduce effectively a multidimensional person with work experience and mental abilities and skill sets and all of these things into just like this one very flawed final metric. So like I said, long-winded. It doesn't. Maybe that's not the answer that you are aiming for. But I do think that the having the right data is we're never going to be able to completely express a person or a situation with just numbers. So making sure that we consider everything and also use statistics to help understand how confident we are in that assessment is important.
So Den might dislike me for doing this, but I'm going to go off the rails a little bit, and I want to know what your thoughts on the recent stock market craziness has been, and why can't you tell me how to use AI to more effectively bid on the stock market?
Man, if I was truly a machine learning engineer, I would have been purchasing GameStop stock back in the day. But
what about crypto, like Dogecoin, like knowing, okay, what's going to take off, how can AI modeling be applied to that type of stuff? I'm really curious.
Or COVID, right? Like how could any of the none of the models that I have ever seen have predicted COVID, or anything similar happening so quickly. Like it's just, there are some things that are just so strange and so wacky that it's very difficult for AI to even guess. And more importantly, like traditional machine learning is trained all on historic data, right? Which means that you can't create new futures. You can only predict what you've seen before. And so I do think that that's one flaw that we all need to be mindful of, is that, there are other worlds that exist and other possibilities, and many of them, some of them worse, but many of them much better. And machine learning can't give us that, at least not traditional methods, but it's just something to remember.
So do they do like fantasy prediction models? Like let's generate a past. Let's train it on a past that didn't exist. Like if one or two things changed, let's train our AI on that. Like, is that a super common way to like model? Like, help me understand that. Like, how does AI model?
Right.
Just, you mentioned that it kind of goes on past events, but like, is there like kind of like, oh, let's cherry pick and change a couple of variables and just see kind of how it runs?
So that's a great question, and it is a way to test kind of the robustness of models. And also see where models could potentially have flaws. But an example, one of my favorite examples of sort of the way a traditional supervised model would make a decision is that you might have, a massive database from a bank with, many different variables about a given person. So, where that person happens to live, their academic background, their name, their age, their gender, maybe, and then how much of a loan they were given and whether or not they defaulted on it. So whether or not they paid it back on time. And if you're the manager of a bank, you care very much about whether they paid back their loan on time or not. And you might sort of be interested in using all of this historic information to say like, okay, well, if I meet a new person that has these criteria, what is the likelihood that they would pay me back my loan on time? And so you can analyze sort of that back history. You can sort of test your model or test it by adding in some maybe flawed examples, and sort of understand, does this model hold up if I move outside of Texas? Does it hold up if I, start considering people outside of the United States? And then also, what is the impact for specific demographics, right? Like there's, these models were being used by banks for many, many years without realizing that zip code is very much tied to socioeconomic status and race. And if you consider, sort of look back and sort of consider some of the recommendations that the model was making, they were saying often that, white men should be given loans, and then, women or people from other races would be less likely to pay them back on time. Which is, completely that's a whole nother hour-long conversation. But ethics in AI, again, I think that's one of the most important reasons why we need to have people from diverse perspectives, diverse backgrounds, all coming together to have these conversations about data and about accuracy and about whether or not we're measuring the right things. Is because, if you only ask one kind of person, then you're only going to get one kind of answer. And it's probably not going to be the right one. So
biased data sets produce biased results.
Exactly.
And it's very easy. And I love the point that you made about these hidden biases, where it's not necessarily where there's a flag that says what ethnicity a person is from, but just by zip code, right? Somebody looks at the surface and I said, I didn't even take this data in the account.
Yeah.
It's a zip code. But the zip code alone can say so much. Exactly.
And it's also like every data collection method is biased. It's like every single one. And it's just a matter of how pervasive that bias is through the data set. Like even there's a data collection, project within Google that sort of encourages, like the crowd sourcing of many different image types. So an example of this would be if you think of marriage in the United States and like pictures of marriage, you're probably thinking of like white dresses and tall cakes or whatever. And that concept in photos looks very different if you're in China or if you're in India, right? And so the motivation of this project was to encourage people from all over the world to take photos and then to tag them with specific terms so that they could be used for image recognition projects. But that is also biased in the sense that people have to have phones. And if you have a phone, like an iPhone or whatever it is, you're probably coming from a very specific socioeconomic status, which means that many other people from other socioeconomic statuses won't have their experiences captured as part of this model. So biased data collection mechanisms, like I am just so fascinated and impressed by the people who do work in this space, because I would have never thought about it. And then after reading a couple of papers, it just makes you realize, like, how can I be sure of anything going down the road? So
it's interesting too, because you called out the fact that there is the human interaction in AI, and I think this is another point that is so often missed, is that AI, it's not just throwing data at a problem and the machine will figure it out. It'll just come up with the right answer. There's humans involved.
Yep.
Humans are biased by default, like no matter where you are. And if a human is involved in the problem, then you end up with, well, we see every once in a while these kind of occasional results.
Mm-hmm. Absolutely. And there's, it also working in this space and thinking about ethics in AI quite a bit really over the course of the last couple of years. It makes you start to be more mindful about human processes and systems and start questioning them a little bit more as well. Because, just as algorithms can make these really, really terrible assessments, you start thinking about like, well, what about judicial systems? Like, what about all of these things that when you were younger, you kind of just took for granted as being, correct and obvious and like, obviously they're right. And then you start thinking about like, well, no, wait, like there are all these other cues and what's worse is that these sort of human algorithms for decision making are often, even less understandable than the machine learning models that are making their choices. So I don't know, like if anything, machine learning has made me more confident that we need to have people constantly questioning things that we believe to be true. Or things that we believe to be right. I feel a lot more appreciation for humanity after working with computers than I would have ever expected, growing up. So like computers are magic, but the people parts are the hardest part.
So one thing that you are involved in is contributing to open source projects, and for someone that wants to kind of follow in your footsteps, I know it can be intimidating sometimes to just get started contributing. Like you don't know what to do and you feel it's like, you're the new person there and you don't really know what to pick out or work on or help with. What would be your advice to kind of getting started, getting yourself out there when it comes to open source? If you want to provide your perspective and you want to get involved and add some diversity to a project.
Yep. So that's an excellent question. Open source can use every single type of skill set, not just programming. So if you're a designer and you want to create a logo, if you're a tech writer and you want to create documentation, if you're like a content person, or if you're really good at SEO or social media, those skills are used and very much needed throughout the open source community as well. So no matter who you are, your unique skill sets can be useful to an open source project. So don't feel like you have to be making programming contributions or any of those other things. And if anything, like I guarantee you the open source maintainers will just be delighted to have somebody that isn't necessarily asking about pull requests, that can contribute in these ways that, they probably don't have bandwidth or the skills required to help themselves. So certainly get involved however you feel most comfortable. And then also, if you're interested in programming contributions, Google Summer of Code is a great way to get started and to get paid. Outreachy is also a way to have an open source mentor, if you're from an underrepresented group, sort of guide you through an open source project and making your first contributions. And then also GitHub has a tag called Good First Issue, which is usually an indication that this is a relatively straightforward code contribution. And also the maintainers have the mental cue that, okay, this person is taking on this issue. That means they're probably a beginner. I can sort of mentor and guide them a little bit more than I normally would for pull requests.
So it's like the shallow end of the pool. It's the kiddie pool, right? Like
exactly.
Get your feet dipped in and get a little warmed up.
Yep. And tech, like documentation, tech writing. I have so much respect for technical writers. Like it is one of the most challenging skill sets to develop, I think, because and also UX research, to be honest. Like it's the because you have to kind of understand the technical space, but you also have to have user empathy. You have to understand a little bit about psychology, and for tech writing, a little bit about effective communication and how you would structure sentences and all of these things. And every open source project that I have ever seen can use more like corrected technical documentation. Like I think, and every open source survey over the course of the last half decade, like the primary complaint from every user is like, man, technical documentation, sure do wish that was better. And Den has extensive experience in this space and can speak to it much better than I can. But technical documentation is a great way to get started with open source as well.
Everyone wants to talk about technical documentation. Nobody wants to do it. So
Yep.
I'm glad that there's somebody like you that's advocating for it too. I'm all
Awesome.
So what would be, as we kind of wrap up here, if somebody was to carry away a piece of career advice from you, what would you say?
Oh man, like I am not the right person to be asking for career advice. So, fun fact: when I was in the earth sciences, I got told that being interested in Python and being interested in computer science were wastes of time. Like nobody would ever need those skills. Nobody in earth science would ever care about or respect them. And it was actively harmful for my career to be interested in doing work in these spaces. Hadley Wickham, who is chief scientist for RStudio, he's the author of many tidyverse packages in the RStats community. I believe he had a similar situation where in the academic world, like building developer tools is not respected as much as like publishing papers and results and getting citations from those more traditional means. And so people would tell him like, it's great that you're building these R tools, but that's not going to be useful for your career and is actively harmful for it. And so my approach towards that feedback was effectively like, that's great that you have that opinion, but no, thank you. I'm going to continue doing the things that I enjoy, and hope it works out in the end. And so that is the approach that I've been following my entire career is I'm going to do what I enjoy and what I find to be useful and where I derive meaning. And I'm going to hope it works out in the end. And so far it has. But that is, maybe not the best advice to be giving to the younger generation. But if you do really enjoy a space or a series of spaces, like go after whatever your passion happens to be, and there is a way to make it work. And also there is, I think I said this before, there is magic in the margins, right? Like you don't have to follow this formulaic recipe of a career path, in order to be successful or to have a meaningful workplace or work challenge. Like you can do all sorts of things, and like just be creative. And yeah.
As we wrap up, I do have one last question.
Yep.
So for people that want to follow you on Twitter, on any other channel, because I know Twitter because that's where I hang out. I know that you hang out a lot.
Yep.
And everyone should follow Paige on Twitter, period. But where can people find you if they want to learn more about what you do and your adventures?
Awesome. So I am dynamic web page pretty much everywhere on the internet, Twitter, GitHub, etc. Like, please feel free to always ping me on Twitter or, reach out via GitHub. My email address is also available there. But I would be delighted to hear from folks. Thank you so much for having me today. This has been really, really fun, and a great discussion, great conversation.
It's always extremely nice talking to you, Paige. And I come, from a background where AI was not my thing that I originally even stepped foot on. So I feel like today was, again, a fire hose of just like learning and learning. And now I just want to go to archive and start browsing even for more papers. So, and thank you for your time.
Awesome.
Yeah, thank you so much for coming on and explaining things to me in a way that I could understand.
Excellent. Thank you. Thank you for asking questions. They were great ones.
Thank you, Paige.
Yep.